Okay, so this is the Wilcoxon-Rank-Sum Whitney test. They're pretty much now, this is basically two different names for the same test. But do realize that the test statistics are a little bit different. So they do not carry across, but the p-values and the results of the test should be exactly the same. But we're going to deal with the Wilcoxon-Rank-Sum version. That's the one we're going to do. Now we see here two pieces of data. We have a set of government economists, economists working for the government, and a set of university economists. And they're making predictions of the kind of cost of living inflation change in the next year. And what we've done is obviously there's two groups here. So this is the equivalent of the two group independent samples test. And we're going to be ranking these predictions. Now note the ranking is across both sets of predictions. We can see here that the rank 1 is prediction of 0, rank 2 is prediction of 2.3%, 3 is 2.9%, 4 is 3.1%, and then we go over to the university economy and rank 5 is 3.9%. And then we carry up until everything's ranked. Now, ranking is sometimes done in this kind of opposite order to the values, i.e., the top is ranked first, but we're not gonna, and that should give equivalent but opposite results. But again, we're going to try and avoid that. So we're just going to we've got some numeric data, and then we rank the data. The ranking is across both of the groups. Now here is the test, and I've just kind of put it on my. I've done a snippet of it, so it's on my thumbnails. So we have two groups here. And if we look at this, we're thinking about D1 and D2, our distributions. And the null hypothesis is always that the distributions are identical. Just getting used to this pen. I've not used it for a few months. And that would be I'm just going to use wavy lines for equivalent to the independent samples, but it's not what we're doing, is mu1 equals mu2. Now notice we have the alternative hypothesis, and let's just start at the two-tail. D1 is shifted either to the left or to the right of D2. And for the alternative hypothesis, D1 is for the one-tailed test, D1 is shifted to the right of D2, or D1 is shifted to the left of D2. So let's just think the two-tailed. I'll put two-tailed. We've got the HA of D1 is shifted either to the left or right, and you've got it to the right. So I'm not going to do the full one, the left or right. And that's going to be equivalent for the kind of equivalent parametric of mu1 is not equal to mu2. And then let's go to the one-tailed right. And that is D1 is shifted to the right of D2. That would be equivalent of, what's happened to my pen? Mu1 is greater than mu2. And if we had the shift to the left, that would be mu1 is less than mu2. Okay, now the thing is, we're thinking by the distributions, we're thinking about the shapes of the distribution. So let's do this. So we have let's just say we have D1 is shifted to the right of D2. we don't necessarily have to have the same shape. We just need to have the distribution. So imagine that this is D1. And let's just pick another color. Let's just do green. Is going to be kind of shifted to the right of D2. Now we're just thinking of distributions, but there's like a special case. Okay, that was the wrong color to use. There's a special case. I don't know what happened there, but anyway, let's carry on. There's a special case that if the data are fully numeric or fully continuous, and the distributions have the same shape, then this is a test, then this is a median test. I.e., say for H0, that would be median 1 equals median 2, and HA median 1 is not equal to median 2. But we're not going to make those assumptions because, it's very hard to say one distribution has the same shape as the other. So we're just going to focus on the one in the slide. Okay, so let's kind of go back, and I've put this example on a spreadsheet. So first we actually and we did all the ranking in order. So we put all the percentage changes in order, and then we kind of read it by groups. But you can see we have 1, 2, 3, 4 are all in group 1. 5 is in group 2. 6, 7, 8, 9, 10, 11, 12, and 13. Oh, sorry, 6, 9, 10, 11, and 13. 10, 11, 12, and 13 are all in group 2, but 7 and 8 are in group 1. So we're actually, we extract the ranks for group 1, we extract the ranks for group 2, and we create something called a rank sum. That is the sum of the ranks for our actual hypothesis test. So again, let's go back to our little cutout version. And let's actually just give me a second, I'll create another cutout version. Okay, so we have our cutout. Let's just have a look at our rank sum. So we've basically, all we've done is we've summed the rankings for group 1, and we've summed the rankings for group 2. So as an interesting aside, the sum of these ranks is the 25 and the 61 is always equal to the same value, which is n times n plus 1 all over 2. So I've done another cut. So let's just kind of think about this. So our n here is going to be 13. So our total n is 13 because we have 13 raters. Now, our kind of rank sums, T1, we'll call it, is the rank sum for group 1. T2 is the rank sum for group 2. And we're going to say that T1 plus T2 equals n times n plus 1 all over 2, which is equal to 13 times 14 all over 2, which is 182 over 2, which is 91. Which should actually verify that this equals to 25, that's plus 60, 85 plus 6 is 91. Okay, so now let's go back to our test. $25 and 66. Okay, so we're going to have T1 is 25 and T2 is 66. And we're going to do the two-tailed test. So I will actually kind of write this one out. Just note here that the upper test, we're looking for D1 is going to be shifted to the right of D2. Now, a key thing here is the test statistic is we basically always use the smallest group. So the test statistic is going to be the smallest group, where N1 is the number of items in group 1 and N2 is the number of items in group 2. And if you're doing an upper test, then we're going to see if it's greater or equal to TU. And if it's a lower test, then we're going to see if it's less than or equal to TL. Now, likewise, if the rank sum is for the other group, now remember this is almost the parametric equivalent of, mu1 minus mu2. So say you're doing an upper test of, if you were doing an upper test of the D1 shifted to the right of D2, i.e. the equivalent of what would have been for parametric mu1 minus mu2, then for the upper test, then group 2 should be smaller, and for a lower test, it should be bigger. So if we're testing group 2, we're kind of swapping it around. The nice thing with the two-tailed test is we still use the smallest group, but it doesn't really matter. We just have to reject if we're less than TL or greater or equal to TU. And I'll just quickly, before I do it for this one, I'll just quickly show you the table. Here we go. So here's the actual table. This is in the handout book I gave you and in the slides, and it'll also be, of course, on the exam. So let's just kind of look at this. We have the group size for N1, we have the group size for N2, then we go across to the group of N1, and we go down for the group of N2, and this gives us the TL and the TU. So let's just try it for this example. Let's get the right one. Okay, so let's just do this whole thing and put it all together. So H0, we have the distribution for government and again, if you want to be, you can still just use D1 and D2 in the exams. Government and university economists are identical. And then HA, let's just do two-tailed distribution. For government economists is shifted to the left of the distribution for university economists. The test statistic is just going to put here T equals T1 as N1 is less than N2. So our rejection region Okay, let's go back to the slides. Our rejection region is basically we reject if TL is less than 28, less than or equal to 28, or greater or equal to 56. Remember that we've actually got, in the rejection region, it's a less than or equal to. So we're going to reject H0 if T is less than or equal to 28 or T is greater or equal to 56. I'm running off. Yeah. Okay, so it didn't like me going off. Yeah, that's the edge of what I'm allowed to use on the screen. So we reject H0 if T is less than or equal to 28 or T is greater or equal to 56. I'm just going to stop the video and I'm just going to show you the main version of the table. Okay, so here we go. We actually had, if you go back again, we have 6 government economists, 6 in group 1, 7 university economists in group 2. Then we do 6 across, 7 down, 28 and 56. So this is alpha equal 0.05 two-tailed. If we were going to do alpha equal 0.01 tailed, then we'd utilize table 2. So let's just kind of go back to our little snipping. Okay, so we're going to calculate the test statistic. We're going to say T equals 25, is less than or equal to 28. So reject H0. There's evidence that the distributions are slightly different. And in fact, if we look back at the data, we'll see that the economists obviously are pretty, group 1 is kind of lower than group 2. So alternatively, we could have done, a one-tailed lower. And let's just get the snipper. With a one-tailed lower, group 1 is smaller, so we reject if T1 is less than or equal to TL. If we go back to our table, so if we did a one-tailed, we'd have 6 and 7. We'd reject if it was less or equal to 30. If we were doing the one-tailed test, we would have done reject equals not if less than or equal to 30. So I don't think I put it down. So just a reminder here, the rejection region, that's going to be alpha equals 0.05. Okay, and that is the Wilcoxon-Rank-Sum test. Relatively simple. It's the equivalent of a parametric independent samples test. The only thing to be a little bit tricky about is with the one-tailed test, do note that if your second group is the smallest group, then you need to kind of flip and reverse everything. The two-tailed test is definitely easier because it doesn't really matter which way round things are as much. Okay, and that's it for the Wilcoxon-Rank-Sum.